Hello viewers, welcome to add-on. In this question we are asked, draw and explain the circuit which is required to produce the output given in the figure B, which is when the input is in the waveform which is given in the figure A. So this is our input waveform and this is our output waveform. We can see that the input waveform, there is a particular sinusoidal waveform, okay. So this has a peak value of Vp and in the negative half cycle this has a minus Vp peak value. So the positive peak value is Vp and the negative peak value is also Vp. Okay. So what we have done here is we have clipped the portion of the waveform of this particular waveform from this particular portion. Let me show it by this. So this is the waveform. I have just uh, clipped this particular waveform at this particular point. Okay. So this portion will be clipped off. The portion I am red marking it. This portion is particularly clipped off and only the black portion will remain. Okay. And this particular point in the question it is given that 0.7 volt bias is given. Okay. Which is the condition for this particular clipping. So let us draw the circuit and let us understand how this circuit works. Okay. So as we know, if you want to clip a particular portion of the waveform, we will use clipper circuit. So the main circuit that we are going to use here is clipper circuit. This is clear, right? And now the question arises, which clipper circuit are we going to use? There are series clipper, there are parallel clipper. So we can use either series clipper, either parallel clipper. And in this question, I am using parallel clipper. And as we are clipping the waveform in the positive direction, I am using parallel positive clipper with positive bias. As we can see here, that the bias is given here is positive, which is 0.7 volt. Okay. So let us draw the circuit of it, parallel positive clipper with positive bias. So this is the circuit diagram. I am applying the input voltage here, this is V in, or here in this case, this is Vp. Suppose I am assuming this is V in. Then we will connect a diode. This is the diode. Then we will apply the bias. The bias value is 0.7 volt. This polarity is plus, this polarity is minus. And across this diode, we will be taking our output voltage. Okay. So this is the main circuit which we will use to generate this output waveform. Now, how does this circuit works? There is the question. So as we know, this is the AC power supply, right? So this will have two half cycle. One is a positive half cycle, one is a negative half cycle. So if you consider the positive half cycle, this is positive and this is negative. Okay. And this diode has two sides. This is P and this is N. Okay. So as we know, if P is connected to the positive terminal, then the diode is forward biased. And if N is connected to the negative terminal, the diode will be forward biased. So if P is connected to the positive terminal and N is connected to the negative terminal, the diode will be forward biased. And if the reverse situation arises, if P is connected to negative terminal and N is connected to positive terminal, the diode will be reverse biased. So as we can see, the P here is connected to the positive terminal. But this is not the real case, because the bias which we are applying here is 0.7 volt. This will also have a polarity of plus and minus. So the N terminal is also connected to a positive terminal. We have to determine which of this P or N, terminal is connected to a more positive value. Which means P is connected to a positive terminal and N is also connected to a positive terminal. So I have to determine whose positive value is more. Suppose this positive value is 5 volt and this positive value is 10 volt. So here N is relatively connected to a more positive value and P is relatively connected to a less positive value. So in this scenario, the diode will be reverse biased. But if I am assuming that this positive value is assuming 10 volt and this positive value I am assuming is 5 volt. Okay. So if this particular scenario arises, then P is connected to a more positive value and N is connected to a less positive value. So during this case, diode will be forward biased. So here the main condition is, suppose at this P terminal, here the voltage is what? V in positive for positive half cycle. And at this particular point, the bias voltage is what? Suppose I am assuming this is VB of positive, where VB is the bias voltage. So if V in of positive, if the positive voltage which is applying at the P terminal is more positive than VB of positive, then the diode will be forward biased. And if this voltage value VB of positive, which is applying at the N terminal, is more positive than V in positive, which is the voltage I am applying at the P terminal, if this condition arises, then the diode will be reverse biased. So as we know in the parallel clipper, if the diode is forward biased, current will flow within this loop and the current will get shorted. So we won't get any output across these two terminal. Okay, we won't get any output across these two terminal. And if the diode is reverse biased, then this diode, if the diode is reverse biased, this diode will act like an open circuit, and the voltage which we are applying at this particular point, we will also get this voltage across this point. Okay, so for this particular condition, VB of positive greater than V in of positive, this is the condition for which the diode will conduct. Okay, and this is the case of positive half cycle. And in the negative half cycle, there is no case of biasing, because the P terminal, this P terminal is already connected to a negative pole. I am explaining it here. So suppose during the negative half cycle, so the bias polarity is plus minus and the battery polarity is minus plus. So the P terminal is connected to a negative. This is connected to a negative pole of the battery, and this N terminal is connected to the positive pole of bias. So during this case, the diode will be already reverse biased. So the diode will act like a open circuit. So we will easily get the output voltage here. So what happens is that during the positive half cycle, suppose this is a sinusoidal waveform. During the positive half cycle, we will only get the output voltage up to the point when V positive is greater than V in positive. And as soon as this condition exists, we will get the output voltage. And as soon as this condition gets violated, when V in positive becomes greater than V positive, we won't get any output voltage. And during the negative half cycle, as we can see, the diode will be reverse biased. So we will get the entire negative cycle at the output. So what happens is that for the input voltage, I am assuming for VV positive greater than V in positive, the diode will be reverse biased. So I am assuming VV positive is this particular point. Okay. So up to the point VV positive is greater than V in positive, the diode will be reverse biased. So this is the input voltage which is given in the diagram. This is the input voltage. This is V in. Okay. This is V in. So the V in goes like this. This is the input voltage that I am drawing. And as soon as the V in reaches this particular point, at this particular point, the current, or we can say the output, will saturate. Because if we go beyond this point, then the condition becomes V in positive greater than V positive. So during this condition, here we can see the diode will be reverse, the diode will be forward bias, and we won't get any output. So during this particular point, the waveform gets saturated like this, and during the negative half cycle, it will be just same as the input waveform. So as we can see, this output waveform and this waveform is same. Only difference is VV positive. So as I have said at the beginning, I am assuming the bias voltage 0.7 volt as VV. Okay. So this voltage, this is equal to plus 0.7 volt. So this is the output waveform that we are asked here. So I hope we can all understand the explanation. We can understand the explanation how we are getting this output voltage from this input voltage using this parallel positive clipper with positive bias. Thank you.